The topic for this lesson is higher index radicals. So we're going to talk about what we mean by an nth root. We're going to simplify higher index radicals. We're going to rationalize denominators. And we're also going to perform some algebraic operations, all with higher index radicals. So the definition of a higher index radical, we basically say that the nth root is, so the nth root of a means what number must we raise to the nth power in order to get a. And so this little n here, that's called the index. And depending on what the index is, that tells us what kind of root we're taking. So notice that the index is always an integer, greater than or equal to 2. And you can see when it's 2 it's a square root, when it's 3 it's cube root, 4 means fourth root, 5 means fifth root, and so on and so forth. So 11 would mean 11th root. And when we don't know what n is, we just call it the nth root. Keep in mind that the product and quotient rules still apply as long as the indices are the same. So for instance, I can say that the cube root of 2 times the cube root of 3 is the cube root of 6, but I cannot say anything about the cube root of 2 times the fourth root of 3. They're just not the same index, so I really can't simplify that any farther. All right, so let's get into some simplifying. So you can see here we're taking the cube root, so I'm going to break it down into factors, but instead of factors where 1 is a perfect square, I'm now going to break it into factors where 1 is a perfect cube. So we can think of this as the cube root of 27 times the cube root of 10. Therefore, we get 3 cube root 10. Remember to bring along the index, right? Because without the index, right, if we had no 3 here, like so, that's a very different thing. So we want to make sure that we include the 3 and also make sure it kind of fits nicely inside the little nook of the root sign so as to not be confused as an exponent on the number that's out in front. All right, so 3 cube root of 10 is the final there. So now we want the fourth root of 48. So we have to find something that is to the fourth power. And so if we break this into 16 and 3, we know that 16 is 2 to the fourth power. So when we take the fourth root, we can bring the 2 outside, and the 3 stays inside. So it's 2 fourth root of 3. Here we have a fifth root, and I'm going to break this into 100,000 times 4, and the fifth root of 100,000 is 10. So this is 10 times the fifth root of 4. Notice here we have a negative inside the root, and because it's actually the cube root, this isn't undefined. This is negative 5, because negative 5 raised to the third power will give us negative 125. The fourth root of negative 16 is undefined, because there is no way that we're going to multiply a number by itself 4 times and end up with a negative, right? So if the index is even, you cannot take that root of a negative number. And with variables, we kind of treat it the same. So I've got the cube root of 8, so I'm going to leave that, so that's going to be a 2. J to the 7th, I can think of that as j to the 6th times j. And I can take the cube root of j to the 6th, it's j squared. That's hard to say, j to the 6th. K to the 6th, I can take the cube root of that, that's k squared. And then L to the 11th, I'm going to break into L to the 9th times L squared. And the cube root of L to the 9th is L cubed. And so what I still have inside the cube root is that leftover j and the leftover L squared. So that's how we simplify higher index radicals. We just look for a power that matches the index so that we can take that root. Now for rationalizing the denominator, remember that we want to multiply top and bottom by the same thing to get rid of the root. Well, here we're going to multiply by the cube root of 4. And the way that I came about that is I have the cube root of 2. If I multiply by the cube root of 2, I end up with the cube root of 4, and that is not something I can take the cube root of. So what I actually need is I need 2 more 2's, right? So it's technically the cube root of 2 squared that I'm multiplying by. So now when I multiply these, it's the cube root of 2 cubed, which is 8, and we know that that is 2. So the denominator is 2, and I have 6 cube root of 4 on the top. 6 and the 2 cancel, giving me 3 times the cube root of 4. Now in this problem I have a 4th root in the denominator, so that means I need a total of 4 2's down here. So I'm going to multiply by 2 to the 3rd. So the top is 6 times the 4th root of 8 over 2. We can simplify that to 3 times the 4th root of 8. Here I've got the cube root of 4, so you may be thinking, well, let's multiply by the cube root of 4 squared. And that would work, but we can do something a little more efficient. Because 4 is already 2 squared, I only need one more 2. So now when I multiply these, I will end up with the cube root of 2 cubed, which we know to be 2. And so 6 cube root of 2 equals 3 times the cube root of 2. Why don't you try multiplying by the cube root of 4 squared on the top and bottom and see if you end up with the same thing. And then here, 4th root of 8, let's think of 8 as 2 cubed. So instead of multiplying by the 4th root of 8 cubed, I'm just going to multiply by the 4th root of 2, because that'll get me the 4 2's that I need to be able to take the 4th root. So 6 4th root 2 over 2. And there you have it. So that's rationalizing the denominator. Again, notice in each instance, we got rid of the root in the denominator. And now for algebraic operations, keep in mind that the index must be the same. So if I simplify this first root, the cube root of 64 is 4, multiplied by the 3 outside, that's 12. X to the 4th, we can think of that as x cubed times x. Cube root of x cubed is x, and that leaves me with a cube root of x inside. I can take the cube root of 8, that's 2, multiplied by the 5 outside, so that's 10x, and I'm left with a cube root of x. So here, since I have the cube root of x in both terms, I can actually combine them and end up with a 2x cube root of x. So that's how we work with addition and subtraction. Just make sure you are adding like roots. And then finally here, we can distribute this. So this is the 4th root of 2500 plus the 4th root of 65. 2500 is 625 times 4, and we can take the 4th root of 625. It's 5. So we have 5 4th root of 4 plus 4th root of 65. And I can't do anything more with that, so it is complete. And there you have it for higher index radicals.